On April 23, 2004, an explosion at the Formosa Plastics Corporation facility rocked the small town of Illiopolis in central Illinois. 5 workers died, including a husband and wife. 3 others were severely injured. Authorities evacuated approximately 150 residents from the area. The incident had serious economic consequences for the surrounding community, as the plant did not reopen. The facility, which employed 139 workers, produced PVC, a common plastic. PVC is used to make many different products, including credit cards, clothing, pipe, siding, and flooring. Borden Chemical constructed the plant in 1965, and Formosa purchased it in 2002, 2 years before the accident. The CSB investigated the incident and issued a report with findings and recommendations.
This explosion occurred after a worker opened a valve on a pressurized reactor full of flammable material. It might be tempting to simply blame the tragedy on human error. However, as is often the case, the root causes were much deeper.
The CSB investigation revealed that better operating practices and equipment design could have reduced the chances of human error that had such catastrophic consequences. The CSB used physical evidence, documents, and the testimony of the few surviving witnesses to reconstruct the accident. The following computer simulation shows how events likely unfolded. The Formosa plant made polyvinyl chloride, or PVC, in 24 large vessels called reactors that were arranged in groups of 4. Inside each vessel, thousands of pounds of highly flammable, toxic vinyl chloride reacted under heat and pressure to form PVC. An operator controlled the process from a panel on the upper level. When the process was finished, a second operator would walk down the stairs and open valves on the reactor piping to transfer the product out. After completing the transfer, a worker back on the top level would then clean out the inside of the reactor with a high-pressure water blaster. The worker would then go to the lower level and open the reactor bottom valve as well as the drain valve. Water emptied onto the floor into a drain. On the evening of the accident, an operator started cleaning reactor 306 with the water blaster. He then walked downstairs to drain the water out of the reactor that he had been cleaning. But he made a critical mistake. The CSB concluded that instead of turning left at the bottom of the stairs to get to reactor 306, the operator turned right to a different group of reactors and approached reactor 310. But reactor 310 was not in the cleaning process. It was pressurized and heated, in mid-cycle, making PVC. The operator turned switches to open the reactor bottom valve and the drain valve. The drain valve opened, but the reactor bottom valve remained shut. An interlock blocked the air supply to the valve's actuator. It was designed to do this as a safety measure when the reactor was under pressure, to prevent an accidental release. But instead of checking to see why this valve would not open, the operator decided to bypass the interlock. He disconnected the existing valve air supply hose and reached for one with a continuous air supply meant for use only in emergencies. He connected this hose to the valve. It opened. Suddenly, the highly flammable vinyl chloride mixture began rushing out onto the floor, producing a loud rumbling noise that sounded to witnesses like a jet engine. Workers smelled vinyl chloride, and the vapors triggered an alarm. The shift supervisor rushed toward the reactors. There he saw reactor 310 spraying vinyl chloride onto the floor, where there was already a foaming mixture 1.5 feet deep. Believing he could stop the release, the supervisor raced to the upper level and told operators to open valves, which would relieve pressure in the reactor. The supervisor and one operator then tried to get to the lower level through an interior stairwell, but were stopped by the overwhelming odor of the vinyl chloride vapor. The operator remained on the upper level. The supervisor headed down to the lower level on an exterior stairwell. Just then, the vinyl chloride ignited and exploded violently. Witnesses reported 3 or 4 additional explosions. 4 workers were killed immediately. the 2 operators who had been working at the top of the reactor, and 2 operators who had been on the lower level, including the one who had apparently opened the reactor bottom valve. A 5th operator, who was seriously burned, died 2 weeks later. 2 other workers and the supervisor, who had been in the exterior stairwell, were seriously injured. The force of the explosions destroyed much of the plant, including the laboratory and the safety and engineering offices. It blew off the reactor building roof, knocked down walls, damaged metal frames and piping, and lifted the reinforced concrete floors on the upper levels of the plant. The CSB investigation found that systems and procedures put in place by both Borden Chemical and Formosa were insufficient to minimize the potential for human error. Formosa did not adequately train and drill its employees to immediately evacuate in the case of a major release of hazardous chemicals. Such an evacuation would have saved lives.
One way to minimize human error, the CSB found, would have been to install additional locks or other devices to prevent critical valves from being opened when the reactor was under pressure. Overriding the only safety interlock was all too easy to do, by simply attaching the emergency air hose that hung nearby. Although the reactors were clearly numbered, they were grouped into similar sets of 4, increasing the chance that an operator might go to the wrong reactor. There were no gauges, indicators, or warning lights to inform operators on the lower level that a reactor was processing vinyl chloride. And those operators did not carry radios or have an intercom, so they were unable to quickly check on the reactor status with operators at the controls upstairs. In 1992, Borden Chemical, the previous owner of the Illiopolis plant, conducted a process hazard analysis which stated that the interlock on the reactor bottom valve was susceptible to misuse. Additional safeguards were recommended, but never adopted. Another hazard analysis in 1999 again identified severe consequences if someone opened the bottom valve on an operating reactor. But the analysis incorrectly concluded that the existing safety interlock was sufficient to prevent a serious incident.
Companies need to thoroughly investigate near-miss incidents to uncover any underlying trends or safety weaknesses. Formosa experienced several previous reactor incidents that, taken together, could have pointed to the potential for catastrophic consequences from human errors. In 2003, an operator at Formosa's Baton Rouge, Louisiana PVC plant opened the bottom valve on the wrong reactor, releasing 8,000 pounds of vinyl chloride to the atmosphere. In February 2004, an operator at the Illiopolis plant bypassed a reactor bottom valve interlock, resulting in another significant atmospheric release of vinyl chloride. Formosa then recognized that additional controls were needed, but didn't act quickly enough to implement improvements. The explosion occurred 2 months later. When a large chemical release like this occurs, employees need to get out of harm's way as quickly as possible. Companies need to train and drill their employees to evacuate instinctively. In this case, 2 operators remained on the upper level, trying in vain to slow the release. They and others who remained in the area died in the explosion. Their lives would have been saved had they evacuated immediately.
The CSB identified many ways that the companies involved could have avoided this tragedy. To prevent future accidents, the CSB made several safety recommendations to the company, the EPA, the leading industry association, and others. The CSB recommended that the Formosa Corporation review the design and operation of all its U.S. facilities. The CSB urged Formosa to ensure that chemical processes are designed to minimize the consequences of human error, improve control of safety interlocks, more thoroughly evaluate high-risk hazards, consider all consequences in near-miss investigations, and improve emergency actions, including prompt evacuations with periodic drills. This accident occurred because the companies involved did not look closely enough at the potential for catastrophic consequences resulting from human error. People do make mistakes, and that is why it's all the more important to design systems that take into account the possibility of such errors. Thank you for watching this CSB safety video. To obtain a copy of this video and the full investigation report, please visit our website at www.csb.gov.